So in your previous coursework, you have done VSEPR, valence shell electron pair repulsion theory, largely as a means of establishing what the geometry of molecules like this are. And I have these listed as not organic because even though some of them contain carbons, fundamentally these are straightforward, simple molecules and not the kinds of ones that we're going to be dealing with in organic chemistry. But I would expect you to, at this point, be able to recognize that the electron pair geometry of this is such that you have two bonding things to that central atom, one on either side, which then means that this is going to be linear overall. It doesn't contain a lone pair there, so you have just two things. This would be an AX2 notation. Whereas here, this one has a lone pair disguised on there that I hadn't drawn yet, and so even though at first it looked like it only had three things, in reality it has four things. So the notation for this would be three bonding things, so AX3 with one lone pair, E, AX3E. So the overall geometry for this, the electron pair geometry for this, would be tetrahedral, but then the actual geometry for this would be trigonal pyramidal. And the reason for that is that the molecule does not in fact look like this. It looks in three dimensions rather more like this methane molecule. So in other words, the actual geometry in three dimensions for the molecule looks rather more like that. In other words, there is a lack of a bond up here on top, and so it's like a little tripod with three different hydrogen atoms pointing down. So this would be trigonal pyramidal, even though at first glance it might not look that way. Here, of course, on this oxygen, we have two lone pairs not drawn, which means that the actual electron pair geometry here should be tetrahedral. The notation would be AX2E2. There are four areas in the molecule with electron density, but only two of those are actually present with atoms bound to them. And so the overall molecular geometry here is bent, even if the electron pair geometry is tetrahedral. Methane, of course, is tetrahedral both in electron pair geometry and molecular geometry. And then here, boron trichloride does not have any lone pairs on the central atom. So in other words, it would have just three bonding areas. Its notation would be AX3, and therefore this is going to be trigonal planar. Now, for the purposes of organic chemistry, we don't really go beyond these options. There are some other things that you might need to consider in more complicated stuff. But in inorganic chemistry, you would have learned things about trigonal bipyramid as a fundamental electron pair geometry, and or octahedral, things with 5 things bound or 6 things bound. But in organic chemistry, we only ever really count to 4. There are 4 things maximum bound to carbon atoms, and more often than not, when we are interested in a functional group, there's less than 4 things bound to a carbon. So really, tetrahedral electron pair geometry is where we live as organic chemists. So for not orgo, you need to consider more things, but for the purposes of organic chemistry, you're not going to need to go beyond tetrahedral, almost always. So you should be able to do this already. Make sure that this skill is current.